So we were talking about the ROI and its importance, okay? Whenever they ask for the ROI, this means that we should find what is the value of A, okay, for which the net present value at the end of lifetime, يعني at n equals 30, is equal to 0. Of course, it's not good to have the NPV at end of lifetime equal to 0. We don't want this to happen. But why we calculate the ROI? Because the ROI will be an indication, if you want, for the margin of values of A for which we can do the project. What do we mean by this? And when you calculate for a certain A, let's say A, you say, let me calculate for A 20%, what is the NPV? Okay. If you put A equal 20% and you get a value for NPV that is positive, this is very good. Why? Because you know that as A will increase, this means that the confidence in the future will decrease, okay? And when confidence in future will decrease, NPV will decrease. So your net income will decrease, okay? Now, if you try A 20% and you still get NPV positive, you can say that I can increase A more. Yani ROI is larger than 20%. Let me try, for example, now 25%. If A is 25% and I get NPV negative, I can be sure then that my ROI is between 20 and 25. So if I do just some iterative calculations, I can try, for example, now in between 22, okay? It's enough to get NPV very close to 0. And I will not be able to have it exactly equal to 0. It's fine. Okay, you do some iterative procedure, you do some calculation. Whenever you get a value close to 0, you can say the NPV, let's say, is nearly 22. So if you get NPV at A22 is nearly 0, you say then my ROI is 22. What is the importance of this number? If you get that the ROI is 22%, this means that for any value of A smaller than 22%, the net present value will be positive. And therefore, higher is the ROI, higher this term is, larger the interval you can work with. If I have ROI 22%, this means for any A between 0 and 22%, I get a positive NPV at the end of lifetime. And then for small values of for small values of A like 5%, I have really high value of NPV and my CER will be large. However, if you have the ROI very small, then this is very bad. And if you get ROI 5%, this means that A should only be between 0 and 5% to have positive NPV. So for any discount rate out of this range, of course, I will get negative NPV and my project will be, of course, not profitable. Okay, so please don't confuse between high ROI and high A. It's good to have high ROI because I have a larger interval of confidence rates that I can work with while still having a profitable project. While if I'm talking about A, it's good to have a small value of A because I will have larger confidence in future. Is this idea clear? Yes. Any question on this? Okay, so now in order to calculate the ROI, all you have to do is to put the same equations that we did in the first question, but now A is unknown. In this question, you know that the NPV is 0, and you write the same equation, but with A as unknown. Okay, and you should include the salvage value in the ROI calculation. Who can tell me?
Yes, doctor.
Of course, we should include it because by definition, ROI is NPV at year, ROI is A for which NPV at n equals 30 is 0. So we are doing calculation of the end of lifetime. So we should include the salvage value. So it's exactly the same equation that we started with in the first question. But now A is unknown and NPV is equal to 0. It's known. Okay, and here also in general we solve with iterative procedure. Yani we assume A equal, let's say, you can always start from 15, 20%, and then you can then reduce the interval until reaching the exact value. I know that a lot of students solve it first on the calculator. Okay, it's fine for me, but just to show that you understood the concept, you can do it on the calculator to know the range, but just to show the iterative procedure. Yani, after getting an idea about the value of A, you should just take 2, 3 values to show how you can detect the value of ROI within a certain interval. Okay. Any question on this? Okay. I will move to another problem on wind.
Professor?
Yes?
But are there further variations than this with chapter 8?
Look, we did in yes يعني هلا هن the relations هول هن بس we applied we did a problem that is little bit more complex. يعني you have variation in cost, variation in operation and maintenance cost, and how we do the calculation. يعني just you have to go over the problem and make sure that you are familiar with the technique.
The whole videos online, right?
Yeah, of course, everything is present in the videos.
Thank you.
Okay. Another problem. We'll consider now a wind turbine of cross-sectional area A of the turbine equals to 12 meters square. Wind crosses this area with a velocity of 50 kilometers per hour. So U crossing the turbine is equal to 50 kilometers per hour. Knowing that the upstream velocity is equal to 70 kilometers per hour, and if we do a small representation, okay, if you remember in the course material, I derived for you the relations for wind and how to calculate the Belt's limit, etc. So you should just be familiar with these relations and how to apply them. So you have, let's say, the upstream velocity, U0, which is the velocity of wind, okay? And do you hear me?
Yeah, Professor.
Okay. So you have the upstream velocity U0, and you know that here you have the cross-sectional area of the turbine. So air will cross our cross-sectional area AT. And we know the value of UT. Okay. And if we want to do a small representation of what is happening, you have the wind, and then as it goes through the turbine, you have an increase in area here. This will explain why U0 is larger than UT, okay? Because just from conservation of mass, you have the mass flow rate will be the same here, okay? And you have that m dot 0 is equal to the mass flow rate over the wind turbine, m dot turbine, okay? And since we are treating air as incompressible, you can write m dot as rho times area times velocity. So rho times A0 times U0 equals to rho times A1 times U1. Okay. Rho is constant because we have incompressible flow. So rho can be simplified. And since you have like expansion of the area, so a turbine is larger than A0, which explains that U0 will be larger than U1 or U turbine. Okay. So now this will allow you to relate if you want the velocities. Now, in this problem, they gave us the velocities. We know that U turbine is 50, and we know that the upstream velocity U0 is 70 kilometer per hour. The first question is to find the power extracted by the wind turbine. In the course, we have demonstrated, okay, what is the maximum power that can be extracted by the wind turbine. And we have seen that it's never possible to take all power all power of wind that is present in wind because of what we call the Bell's limit. Okay, so whenever we have such a problem, we just have to apply the relations that we have learned in the material. For example, I will give you, I don't consider that you will know them by heart, but I can give you, let's say, just the value of the power, and you should know what is the maximum power that can be extracted. You should know what is the formula for the coefficient of performance. Okay, and you should be familiar with these formulas. I just give you a hint formula that can help you to deduce the other formulas. And for example, here, I can tell you what is the actual, if you want the power extracted, what is the value of the actual power? We have demonstrated in the course material what is the formula that will give us the actual power. Who remembers how to calculate the actual power?
0.5 times rho times the area times V1
Yes,
cube.
so we should multiply. Yes, exactly. It's equal to, you have several formulas, and depending on what you know, you can use. One first, you have, if you remember in the course material, we have derived two expressions for the power, and we put it equal to each other. We find a relation between U0, U1, and the exit velocity U2. Okay?
Professor?
Yes?
Professor, the thing is, this is the one where you compared the momentum to the energy.
Yes, exactly.
But do we have to? You said it's not necessary to know.
Look, yes, I will, because it involves fluids, and I know that some of you are of different backgrounds. I told you that I will not ask you to derive it, okay?
Indeed.
But just for your information, I explained it in the slides. But
Indeed.
now I will give you, as I told you, I can give you the formula directly, and you should know how to apply it, and you should know the basic formulas and what is the coefficient of performance, what is the maximum power extracted by the wind turbine, etc.
So the coefficient of performance CP, I thought it was a standard we take 0.35, no?
لا هو هلا we'll calculate it together. Okay. So first you have the power that is actually extracted by the turbine is 2 times rho times U1 square times the area. Here U1 in our problem is UT. It's here at this level. Okay. Times A1, which is the cross-sectional area of the turbine, times the difference between U0 and U1. So it's U0 minus U1. Here also you should take care for units, okay? So power, if you want the power to be in watt, then the density rho. Here again, please be familiar with properties of air and water. So for air, you can consider as a value of rho equal to 1.2. So you can take it as 1.2 kilogram per meter cube. You have to convert velocities to meter per second, okay? So your velocities should be in meter per second, and your area should be in meter square. This will give you a power in watt. So we have already area in meters square, it's 12 meters square. But for velocities, we should pay attention to convert them to meter per second. So all we have to do, whenever you want to go from kilometer per hour to meter per second, you should divide by 3.6 because you multiply by 1,000 to convert to meter, and you divide by 3,600 to convert to second. So in total, it's equivalent to dividing the value by 3.6. So you divide 50 by 3.6 and 70 by 3.6, you get the velocities in meter per second. And when you replace in this formula, you can get what is the power that is actually extracted by the wind turbine. Okay. And if you want to calculate the coefficient of performance, what should we do then?
We equate this to half rho AV cubed times CP.
Yes, very good. You should divide this by the maximum power that you can extract from a wind turbine. And going back to the course material, this P maximum is equal to half times rho times the area times U0 cube. Okay, so P max, let me write it here. P maximum is equal to half times rho times the area of the turbine, cross-sectional area of the turbine, times which velocity here? Which velocity we use here to the power 3? The area crossing the turbine or U0?
U0, it's the highest.
U0. We use U0 here. Okay. And then you can calculate the COP because the coefficient of performance will represent the actual power over the maximum one. And to make sure that what the information given for you is accurate, the COP can never exceed the Belt's limit. And if I give you a problem and you get a COP larger than 59%, you can directly tell me that the information I gave you is wrong because it's impossible to get a COP larger than the Belt's limit. Okay, and the value of the Belt's limit is 59%. So always the COP of your wind turbine should be smaller than 59%.
Professor,
Yes?
COP اللي بقلب equation CP, we call it CP?
No, COP coefficient of performance هو هلا تجيب for the turbine هو characteristic للturbine. Okay? هلا if they ask you the last question in the problem, they asked you for the actual power, electrical power produced. Okay? يعني now this is why they gave us the efficiencies. You don't use the efficiencies of the gearbox and the generator efficiency in the calculation of coefficient of performance. Coefficient of performance will just tell you what is the percentage of wind power extracted relative to the maximum possible power extracted. Okay, but now once you get this fraction that you extracted from wind, you still have losses. Yani when the turbine will operate, okay, you have certain losses in the gearbox. You have certain losses when you produce the electricity at the generator level. This is why they gave you two efficiencies, which are the gearbox efficiency and the generator efficiency. So now after you calculate the COP, okay, you can just say this is at the level of the turbine and how much I can extract relative to the maximum that I can extract. But this is not if you want the useful power. Yani P useful if you want. If you want to calculate the useful electrical power, it's equal first to the power extracted by the turbine. And what is the power extracted by the turbine? It's the COP times P max. Okay, يعني you can say if I give you the COP in a problem, you can directly do COP times P max, which is half rho A turbine U0 cube, times now the efficiencies. يعني you have efficiency at the gearbox level, you have efficiency at the generator level, etc. Okay, so this is how you can calculate the value of the power useful. And if I ask you find the overall efficiency of my wind turbine, what should you do? If I ask for overall efficiency, what is the formula that can give us the overall efficiency of the system?
The Pmax.
Useful power
Exactly,
divided by
the useful over maximum. And can you tell me what it should be directly without doing the calculation?
5%.
It's the product of efficiencies. Yani it's the COP times the efficiency of the gearbox times the efficiency of the generator. Why? Because if we want to apply the formula, let us replace together. Okay? If you want to apply the formula, what is the overall efficiency? N overall is equal to P if you want output, which is electrical output, let's say, okay, over P maximum that we can extract from the wind turbine. And now we said that P electrical is equal to what? Is equal to the efficiency of the gearbox times the efficiency of the generator times P extracted. But what is P extracted? P extracted is equal to the COP times P max. Okay, and now if I divide by P maximum that can be extracted from the wind turbine, P max will cancel out and I can get the overall efficiency. And of course, since all efficiencies are smaller than 100%, yani these are smaller than 100%, then the overall efficiency should be smaller than the Belt's limit, which is 59%. Okay. Any question on this?
Professor?
Yes.
What's it called? هيدي even the N overall لازم تبعول السيستم يكون less than 59 مش ال COP less than 59%.
فادي الفويس كتير واطي. Can you try to or to change your location or to place your microphone in a convenient way, please?
Never mind, I figured it out.
Okay. Any other question? Okay, guys, good luck for the exam. And if you need anything, you can contact me anytime, as usual.
Dear, thank you, doctor.
Welcome. Bye-bye.